smartphone and computer memory is evolving, ReRAM, or resistive RAM, is the future of data storage. Let's explore how ReRAM works and begin this journey. ReRAM is a tiny semiconductor memory, faster than NAND Flash and energy efficient. What makes it special? Let's look at a ReRAM cell, the basic unit of this technology. A ReRAM cell has two metal electrodes with an insulating layer between them. This layer changes resistance to store data. Let's see how it switches states to write bits. The insulating layer, often hafnium oxide, is the heart of ReRAM. When voltage is applied, it shifts from high to low resistance, storing a 0 or 1 instantly. Low resistance is a 1. High resistance is a 0. This switch happens in nanoseconds, hundreds of times faster than NAND Flash. But how does it work? The secret lies in a conductive filament. When voltage passes through, ions in the oxide layer move, forming a tiny filament. This reduces resistance, storing a 1. Let's see this process. Oxygen ions in hafnium oxide move, forming a filament connecting the electrodes. This shifts the ReRAM cell to a low resistance state. It happens at the nanoscale. To write a 0, reverse voltage breaks the filament. The oxide returns to an insulating state, increasing resistance. This makes ReRAM extremely efficient and fast. Billions of ReRAM cells form a tiny chip arranged in a 3D grid. These chips store terabytes of data in a small space, outperforming current memory. ReRAM is smaller and faster than NAND Flash. But why isn't it widespread? Production is costly, and durability needs improvement. Let's explore these challenges. ReRAM production requires nanoscale precision, raising costs. Also, conductive filaments can be unstable after many cycles. Scientists are working on solutions. Back to materials. Hafnium oxide is chosen for its durability and resistance switching ability. Other oxides, like titanium oxide, are also being tested for ReRAM. At the atomic level, oxygen ions move in the oxide, creating or breaking filaments. This movement is key to ReRAM's efficient and fast data storage. Think of a ReRAM cell as a nanoswitch. On, a filament forms, writing 1. Off, it disappears, writing 0. This happens in a flash, saving energy. ReRAM doesn't just store data. Its high speed could replace RAM, combining short and long-term memory. Imagine the potential of this technology. ReRAM could make phones faster, AI server stronger, and even support satellites. This technology promises to change how we use devices daily. In AI, ReRAM process data on-site, reducing latency. This makes AI models faster and more efficient, especially for real-time applications. With the Internet of Things, ReRAM is ideal for small devices like smartwatches and sensors. Its small size and energy efficiency make it perfect, but ReRAM has risks. Unstable filaments could cause data loss. Researchers are improving durability to ensure long-term performance. Production costs are also an issue. Creating billions of ReRAM cells with high precision is expensive, but technology is advancing, lowering costs quickly. Look at a ReRAM chip. Each cell is controlled by a transistor, enabling precise data reading and writing in a 3D grid, optimizing performance. Compared to DRAM, ReRAM doesn't need data refreshing, saving energy. This makes it ideal for phones, laptops, and modern mobile devices in space. ReRAM could store data for satellites and spacecraft. durable. Energy-efficient memory is key for long-term missions. ReRAM competes with MRAM and PCM to lead. It must excel in cost and performance. Big companies are investing heavily to bring ReRAM to market. Imagine a future where ReRAM chips store both operating systems and data, blurring the line between RAM and storage. This could reshape the industry. Intel and Samsung are testing ReRAM. In a few years, you might see it in phones and computers. This technology is closer to reality than ever, but durability needs work. ReRAM must withstand millions of read-write cycles without data loss. Scientists are striving to meet this goal. So, how does ReRAM work? From ions moving at the nanoscale to chips storing terabytes, it's a technological marvel, ready to shape the future of data storage. ReRAM could transform the tech world. What technology do you want to explore next? Share your thoughts in the comments for more content. Loved this video? Hit like, subscribe to the channel for more on future tech. Thanks for watching, and see you in the next video.